Class is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody. And this is Dr. Mansour. And today is Sunday, May the 16th. And this is the first session today for the 7 Breath AM. Thank you very much for accepting my request to move the class from yesterday to today because I was in LA for the last couple of days to celebrate the feast or the Eid, as we call it, after the month of Ramadan. So my family, they said that we need some break. I told them that's fine. So I start to listen to them. So I just arrived last night from LA and here we go. So the moment that I make any change, you will find that the computer, the webinar company, they should inform you. For example, today is Sunday, May 16th. We have a session from 9 to 12. And another session from 3 to 4. There is a gap in between, and I inform you that the gap is basically for the PE 7, the surveying class that I'm teaching, surveying class. So they need more help. So I added another session today. You are very welcome to attend. Especially I covered chapter 5 of my surveying book. And about leveling, and we will jump to chapter 6 today. I will go a little bit very quick on chapter 5 one more time so you can attend, because this will be benefit you, because as you know, the surveying chapter I sent to you, which basically I extracted from my surveying class book for the PE. So it is the same material. So you can attend and you'll get benefit from that. I send you the ID. As far as I know, I send the ID for the surveying class to attend it even for free. Don't worry about that. And so today we're going to meet twice, as I mentioned in the email. In the morning, I'm going to cover the AM section. I'm going to cover materials. And after that, I will jump on the surveying in the afternoon. And if you attend the surveying class from 12 to 3, it will be very good review for you. So welcome everybody. I hope that everybody is healthy and everybody is doing fine. And also, I believe I send you a gift. Sometimes I send gifts, and the gift I sent to you, it was like what do you call it? Homework, I believe, or quiz. I don't know what they call it. I have tons of them, and I call it homework. Oh, I call it homework. Oh my God. And you may say, what? We got rid of homework from school, Dr. Mansour. You try to bring it back again to. So this is what I emailed everybody, and I have the solutions, but I needed to work it on your own first, and after that we'll go over it. This is homework. I will start to give you homeworks. Homework number 1, spring 2021. I don't know how many problems is that. It is, I have 2 sets here. Let me take the stable one. So from 1 all the way to 20. So 20 problems of the topics that we covered so far. Maybe there's 1 or 2 problems we did not cover them yet. Please go over them and try them. Okay. And some of them are easy, some of them is straightforward, and some of them are tricky, and some of them they will take more than 2.67 minutes, and some of them they will take only 22 seconds. So the purpose of this is to let you know that on the exam you have to go well prepared. Number 1. Number 2, you have to go with a strategy, and the strategy is get the problems, the easy problems first, and after that jump on the difficult ones, and you can flag, as you know, all questions that you are going to skip, and you can come back to these questions later on. Never leave a question unanswered, because all the questions, okay, and you may be lucky and you may pray to God and may God accept your prayer. So those questions that you don't know, just guess and pray to God. This is the only thing I can say. Chapter 7, which I send it to you. All of you have chapter 7. Okay, materials. This is the numbering system, the new numbering system by the NCEES. So if you look to the NCEES, they have from 5 to 8 questions. The first topic, mixed design of concrete and asphalt, test methods and specifications of metals, concrete, asphalt, aggregates, first asphalt and wood, and finally physical and mechanical properties of metal, concrete, aggregates, and wood. I included all this in this chapter. This chapter is healthy chapter also. It does have a lot of material, and I collected it from all the sources I have. And how many problems oh my God, we have 794 problems, 94 problems. 94 problems. No, not 94, sorry. I switched the numbers. It seems that I'm still sleeping. 49, not 94. Sorry, forgive me for that. So, okay. The most difficult, I'm also wrapping up the chapter of transportation because we supposed to cover it. I added one more session, by the way, next week on the 22nd. Saturday, the 22nd, we're going to meet the whole day from 8, no, from 9. Yeah, here it is. Here it is. The computer send you this. This is what the computer sent to me, or the webinar company. Okay, from 9 to 4. This is on Saturday, next Saturday, the 22nd. I will do all my best to send you the transportation book, which is very, very important chapter. Transportation, sorry, chapter, not book. The transportation chapter is based on my transportation books for the PE. I have a bunch of books for the PE. I extracted the information that you need from these books related to the NCEES only, and this is what I do. And you will learn transportation as if you never learned transportation before. I will do all my best to make it easy and straightforward and focus only on the topics related to the FE7. Okay, so what is after that, I have no idea. I'm working day and night, try to wrap up or to finish this book. The moment I finish this book, obviously I will offer the class again as paid class. And if you are interested, you can come. If you are happy with what I covered for free, you can stay with it, and we'll take it from there. But if I need to add another session or so, I know I am behind, and I'm supposed to cover 9 topics, but I will do all my best to cover as much as I can, and I will help you as much as I can. Okay. Having said that, let's start so we can get the maximum benefit of our day today. So today is 5/16/21, and the webmaster, he's supposed to come here tomorrow at 3 o'clock. I have an engineer, a student just graduated from Fresno State. He's going to help me. He's start to come to the office tomorrow. He is fully vaccinated. I am fully vaccinated, and everybody in the office come to the office fully vaccinated. So as far as the virus, we will do our best to, even after the vaccination, we still need to take all the necessary precautions because nobody knows how the virus maybe in somebody else. We don't know. Let's take all the necessary precautions. So I will make sure that all the recordings that we did so far, it will be available to you guys to watch it. But try to do your best to watch the lecture live like this. And I highly recommend to go and solve problems. You would like to listen again to the lecture, that's fine. It's up to you. But the time you spend to watch the lecture again, I prefer if you can spend the time to solve problems, unless if you like to review a specific topic or a specific section that you missed, or you would like to make sure that you really understand. I have no problem with that, but the practice and the practice and the practice, as I said. So the most difficult part in preparing these chapters, the NCEES, they have list of topics like this. If you go to the NCEES website, you'll find that chapter 7, and here are the topics, and here are the number of questions. But if you go to the book itself, where the equations, the reference book 10.0, you will find that the equations they provided in different order other than the listed topics. And I start to ask myself, shall I follow this order, or shall I follow the equations and the tables and the charts they provided here? I decided to follow the chapter itself, because this is what you are going to see. For example, in the transportation chapter, the one I'm covering, they started, here it is, and even I broke it down into sections, because each section it does. For example, the first section they are talking about here, they are talking about the, first of all, they are talking about, okay, something related to the industrial section about the queuing model. Okay, we're going to talk about that, but this is topic number 1. traffic signal timing, and they start to talk about the yellow time, the red time, and the G sub B, which is the minimum green time required, and so on. And they start to talk about the SSD, the stopping side distance, which is related to something that we're going to. So anyhow, so I decided to follow the NCEES topics. But if you look to the section of the transportation, you'll find that they are listing the topics a little bit different. Let us see here just to verify that. For example, here, for example, transportation. They started with the geometric design, okay, streets, highway, and intersections. So I was in dilemma. Shall I follow this order or shall I follow the order of the equations? And I decided that the following the equations is more beneficial to you, because these topics just a list of topics, but what you are going to see actually on the exam, this. So when you see this equation, y is equal t plus v divided by, you should be able to see, recognize this equation is used for what and what are the parameters. So I prefer to go to follow this, and this is why you'll find that my books follow this. So section 1 and section 2, section 3, and each section I took it, explain it a little bit, and apply the concept by solving many problems. I hope this you agree with me. If you disagree with me, don't take me to court, or instead of taking me to the court, and you are going to lose anyhow if you go to court, okay, advise me. Okay, tell Dr. Mansour, no, there is another way to present the material. I like criticism. I enjoy recommendation. I enjoy, okay, continuous improvement. So let's do that. Okay. For example, here they start with mixed design of concrete and the asphalt. You'll find this section somewhere here is not really the beginning. Test, okay, methods and so on. Test methods, by the way, since I mentioned that, I give the, I encourage everybody to watch these movies. There are 3 DVDs I have. One has concrete and steel testing, the one you did in the undergraduate, which you'll see some of them today. Concrete and also the soils, okay, soils testing, and one is to surveying equipment and methods. These 3 DVDs, I give it to the engineers for free, or I put it in a USB and send the USB, okay, since most of the computers nowadays, they don't have a DVD player, but or we can load it somewhere and we give you the link and you can watch it. I highly recommend you to watch these things. They are very useful, and you might see some questions on the exam related to the testing and the procedure of doing testing and what are the results you can obtained, or you can conclude, or you can determine from the testing. So from all these tests. So we still have a few of you today. I don't know what happened today. Sunday probably. They said that Dr. Mansour is moving the classes, so we are going to. Or today is Sunday, probably they are busy in the morning with the church, and probably in the afternoon they might join us. Okay, but anyhow, welcome for those of you who are here today. Okay, the first section here, you'll find that in the material section, and I'll show it you in the NCEES, they have something related to thermal and mechanical processing. When they produce steel bars, there are 2 methods. Something is called hot roll and cold roll. So the cold working, and you're going to see a picture on the next page, okay, a plastically deforming, a metal increases strength with lower ductility. There is a famous curve, and I'm sure this curve is not in the reference book, but I believe I provided here on the following page, okay. And this is figure 7-1. Okay, this is what is known as the producing the steel while it is hot or while it's cold. If the steel is hot and they squeeze it between these 2 rollers to produce the size that required, is called hot rolling process. If the steel is cold, they call it cold rolling the process. So basically how they come up with the small sheets or small diameters, they start with a big chunk of steel, and after that they squeeze it between these 2 rollers, okay, to produce the smaller diameters or the smaller sizes of sheets if the thickness is required, and so on. So the process could be done while steel is cold and while the steel is hot. This process itself is changing the properties of the steel. So if you look to the curve to the right here, this is called the stress strain curve. Okay, so this is a stress, as you can see here, this is sigma, but they are using F, by the way, and this is the strain, which is epsilon, which is delta L over L. You will find there are a series of stress strain curves here. The hot roll steel is more flexible or more ductile. The word ductility is very important. So this is the hot roll steel. Okay, so the hot roll steel is more ductile. This is ductility. It has high ductility, DUCT ductility. Okay, it's more ductile, and this is something very, very important. Okay, but as we roll the steel while it is cold, you will find that the cold rolled steel or cold work steel is not as ductile as it is. The F sub y will increase, it will go up, but it becomes more brittle, more brittle. How would you know ductility? Ductility is if you look to the amount of the strain at failure. If you look to this versus the hot roll steel, you'll find that the strain at failure here is much, much higher here for the hot roll steel. So I need you to know that the difference between hot and cold, because they might ask you this, by the way, on the exam as a conceptual question, the difference between. So the word ductility here, it is lower ductility. So ductility will go down, okay, or the steel becomes more brittle. Okay, the steel in general is a ductile material, but there is a relative ductility between different types of steels, and we need to be aware of that. Okay, raising temperature causes. Okay, also I need you to be aware of that. Okay, recrystallization or the hot working, a lower process, and with deformation, quenching. I need you to know that. And in steel, quenching, okay, FCC gamma iron, okay, can be result in material, okay, in materialize, okay, instead of equilibrium phase. And this is basically this last statement here. Don't worry too much. This is for the mechanical engineers. They're supposed to know that. But if you know these things here up to here will be a good idea. I talked about the mechanical processing, the cold rolling, the hot rolling, okay, and I used the hot rolled steel bars, okay. And on the following page, I said that the process explained here, I need you to read this. So the reading, I will leave it up to you, because as I said that there are a lot of things to be covered and materials that can be read. I will leave the reading up to you, and if you have any question, you are very welcome to ask. Okay. Problem number 7.1, cold versus hot rolling. For steel, you need to know which of the following is true about the cold and hot rolling steel. Cold rolling increasing the yield and the altitude. This is yes. Okay. The modulus of elasticity for steel is constant for hot. Yes. Modulus of elasticity will be the same, which, as you can see here, the slope of this line, which is sigma over epsilon, which we know E is equal sigma over epsilon, which is Hooke's law, as all of you know. Cold working for steel, okay, lower ductility, and the steel becomes more brittle. The answer is yes. So all of the above, yes, and I selected the answer D because this is true, which is all of the above. So the cold working will increase the yield and the ultimate, but the ductility will go down, and the muscle elasticity will stay the same. Hot rolled steel is more ductile, and I need you to be aware of that. Mechanical properties, you'll find this in the steel, in the NCEES. We talked about strain, engineering strain, and the true strain before. Engineering strain is divided by the L sub O, which is the initial length. But L is called, they call it initial length, by the way. This is how it's written in the book. I don't agree with that. This is supposed to be instantaneous length. Instantaneous, because L sub O is the initial length. I don't know why they repeat it here again, unless this is typo. Instantaneous, okay, length. This is what it's supposed to be, until I verify this number, this definition, because I believe they call it instantaneous length. This is under the materials. So if you go to the material section, you will find, here it is. I showed you, at least if you can follow up. So here they call it L sub O is initial. This is on page, by the way, page 96. If you have the book with you, the NCEES. the NCEES reference book, the reference equation book, 10.0, as we using the most recent one. So they are defining L sub O to be initial, and they defined also L here to be initial. No, I don't agree with that. This must be instantaneous length, because this is the difference between the true and the engineering definition. But anyhow, so I believe this could be a typo, but I put it down as printed until I check to see if they issue an errata to this book or not. But this is supposed to be the instantaneous one. The relationship between the engineering and the true, they are using epsilon sub t. By the way, this is for the true, okay? So the true strain, but they are using epsilon for the engineering. So the epsilon sub t is equal ln. Ln, this is the log to base E, as all of you know, log to base E, and E, this Nabirian number, which is the 2.7182818, and as all you know, though, given index. So this is natural logarithm times 1 plus epsilon. So the true strain is equal the natural logarithm, okay, of 1 plus epsilon sub t. Well, t is the engineering definition. And there is a question you are going to see here, 7-2, which of the following is true? A true strain is always equal the engineering strain. A true strain is always less than the engineering strain. And the word always, be careful, because okay, a true strain equals engineering strain only for a small values of strain, and the true strain equals the engineering is only for a larger value. So we just saw the equation. Epsilon sub t is equal ln 1 plus epsilon. This is the equation that it is given in the NCEES also, by the way, in the book. Here it is. I believe it is given. Here it is. You don't have to memorize it. This is on page 96. As I told you, you have to be familiar with the book very well. And the PDF, how to search a PDF. I believe I mentioned this before more than once. So epsilon sub t, the true strain, is equal the natural logarithm plus 1 epsilon times 1 plus epsilon sub 1 plus epsilon, sorry. So if you look to this, strain is a small quantity, by the way. So this is the true, and this is the engineering. If you, sorry, let me adjust the camera. If you take epsilon, this one here, as 0.0, and I will tell you how I got this number in just a moment. Give me 22 seconds to see where is my calculator. I think I have another calculator somewhere here. Okay, let's say 0.001. Assume that the engineering strain is 0.001 inch per inch. As you know, strain is epsilon is equal delta L over L sub O. This is the engineering strain. This one here, the true epsilon sub t, is equal delta L divided by L, where L is instantaneous. This is the original gauge length. So assuming that I selected a value of 0.001, and you have your magic calculator, and you can say, oh, 1 plus 0.00, 1.001, which is this one here, which is 1, and take the natural logarithm of this. What you are going to get? Anybody can help me with that? Okay, natural logarithm. Okay, ln. What did he come up with? Okay, anybody can help me? I need you the two calculators that you are going to use in the exam. I need you to be familiar with all the functions and familiar with all the keys. And okay, so it is 1.001. Okay, and you take the natural logarithm. Okay, what did you end it with? You ended with the same number, 0.001. Here it is. This is what I ended with. Okay, so for a small amount of strain, and this is small amount, I'll show it to you how did I come up with this. For amount of strain, the true strain and the engineering strain are essentially the same. And this is why you will find that we use the engineering definitions, because the difference between them is very small, especially within the range that we are using for design. So there is no need to really to. So if you look to the stress strain curve, this is epsilon and this is sigma. So for the engineering and the true, both of them, they follow this range, by the way. This within the elastic range, this is F sub y, okay? You will find that the most of elasticity is E, which is sigma over epsilon, which will give you E, as we said that E, sigma over epsilon, are essentially the same. These two here, along this range here, epsilon sub T is equal epsilon. So the true strain and the engineering strain are essentially the same within the elastic range, elastic, which is a range that we are working with for the time being. And I gave you, I said that if it's epsilon 0.001 inch per inch, you will find that epsilon sub T also is 0.001. There is no change, okay? And I hope that all of you got the same answer as I got by entering this number into your calculator. Okay, but as we enter the stage beyond the elastic, which you call it plastic, you will find there is change, okay? And you are going to see that. How did I come with, by the way, 0.001? This, the 1.001 inch per inch. I took A36 steel. A36 steel, it does have F sub Y of 36 KSI or 36,000 PSI. So I said, how can I get this strain? So epsilon is equal the F sub Y over E. So if you look to the 36,000, the one I use for A36 steel, divided by 29 million, this is PSI, and this is also PSI, but the strain we expressed as inch per inch. If you divide these two numbers, probably you'll get a number very close to this one here. If you take 36,000, okay, and you divided this by 36,000, you divide by 29 million. Okay, let me divide here. I got 0.0. Oops, 36,000. Did I increase 0? 29 million, probably. Here we go, divided. Yeah, it's 0.0012. So anyhow, so the point is, this amount of strain is considered a small amount of strain. So I need you to know that. So this is why the answer for this question here, which is a question number 7.2, you will find that a true strain is always less than the engineering strain. True strain equal for a small, yes. And always pick the best answer, by the way, the best answer. And you correct this equation, epsilon sub T is equal ln 1 plus epsilon, and you take epsilon as a small quantity like 0.001, which is yield strain. You will find that these two quantities are essentially the same. Okay, there is a table here, table 7.1. I gave you the difference between. Okay, this is the actual length or the instantaneous length. Okay, I prefer to use the word actual. This is initial, this is correct, but the true, as I told you, they define this as initial. No, it is supposed to be actual or the instantaneous one. So I need you to know, and I gave you, and this is, usually we use this in design, because the difference between the engineering and the true is small within the elastic range. So this is much easier to measure in the lab, so we use the engineering definition. The same story for stress. We have two types of stresses. We have sigma, which is the engineering one, and something is called the true stress. The difference between this is the A. This is the original cross-sectional area of the initial, but the A is the actual cross-sectional area, actual or instantaneous. The moment that you instantaneous, okay, the actual at the moment of the measurement. Okay, so I know I need you to know the difference between the engineering definition and the true definition. And if you flip the page, you will find continuation of the NCEES. Okay. All these things are given, by the way, in the book. I did not, let me see if I can locate it for you guys. Here it is. This is on page 99. Page 99 of the. So I am following exactly the NCEES as far as the symbols and notations and the terminology they are using and the definition they are using, because I need you to pass. Okay, sometimes we are using a little bit different notations from for the PE from what is listed, but I need you to be aware of. So this is Hooke's law. Do you remember Hooke's law? Here it is. Sigma is equal E times epsilon. I defined it all, the ductility, the ultimate, and the yield. I need you to read all this. And you need to understand every single term. By the way, modulus of elasticity, sometimes we call it Young's modulus. Young's modulus, as a British scientist, his name is Young, Professor Young. So sometimes we call it Young's modulus or modulus of elasticity E, which is constant, 29 million psi. Where did you find the 29 million psi? Do you remember? I covered this in the mechanics of materials. This is the difference between the engineering and the true stress. And here we go. Define all these equations before. This is exactly from the NCEES. Young's modulus, here it is, or modulus of elasticity. Okay, modulus of elasticity, I need you to be aware of that. Okay, it's a property and it could be in PSI or KSI. Okay, series of stress strain curves, they are very, very useful. Okay, I need you to know the naming, plastic zone, elastic zone, and proportional limit, yield. Okay, the design, this is the one we use it for design, by the way. This is F sub U, which is the ultimate, the one I showed you in steel. Manual, and F sub Y is the yield. This is the offset method. Offset method. We talked about the offset method before. So if you flip the page, you will find that problem 7-3. And bear with me. I know there is a lot of material today, and you are telling me that you are devoted your life to pass this exam. So I'm trying to do my best here. Okay. Log E. No. I'm not asking to find the log E. No. Log to base E. Log to base E, my friend. I'm not asking to find log E. I'm saying that log, the logarithm, either to be to base 10 or log to base E. They call it the log base E, call it ln. Okay, so this is what I meant, okay? And the E is 2.7182818. I am not asking to find the log of E, no. I'm talking about the log to the base E, okay, is called ln, which is a natural logarithm as I indicated, okay. If you look to problem 73, please. Which of the following is true? A true stress is always equal the engineering stress in tension. A true stress is always equal the engineering stress in compression, one tension, one compression. A true stress is always smaller than the engineering stress in compression. A true stress is larger than the engineering stress in tension. If you look to this, the stress strain curve, I told you up to the elastic limit or the yield, this is F sub Y, or at the end of the elastic stage. If this is tension test, as the one we did in the lab, you have a specimen and you apply the tension. So under tension, you will find that the stress strain curve, this is the engineering one. This is the one we are doing in the lab, engineering. And this is what the one I'm presenting to you. But if you like to see the true one, the true and the engineering are essentially the same here. But when it comes here, they start to deviate. One will go up and one will go down. The up is in tension. This is a compression. Why the one in tension will go up? Because the sigma T, the true stress, is equal P or F over A, where A is instantaneous. In tension, we apply tension, this cross-section area is getting smaller and smaller, so you divide by a smaller. You divide by a smaller number, you will find that the stress will go up. But for compression, this area is getting bigger, this is why you will find that it is coming down. But as I told you, we are dealing with this range only, and we are using the engineering definition because there is no difference between the engineering and the true within this stage, and we are not interested to know beyond that. But for the sake of the exam, I need you to know the difference between them. This is why I selected the answer. A true stress is larger than engineering stress in tension. Here it is. Okay, so the answer is D. Okay, the remaining answers or the other answers are not. Okay, which of the following is not true about the effect of increasing carbon content on the properties of the steel? Okay, steel, okay, they have low carbon steel and high carbon steel. Low carbon steel and high, and there is some in between, by the way, and don't worry about the percentage of the carbon. If you are interested, I will provide you, but I need you to know. So here we have series of stress strain curves also. You will find that low carbon steel, which is this one here, this is more ductile. As we increase the carbon, what is happening? The ultimate yield is increasing, and the ultimate is increasing, but the steel becomes more. This is medium, and this is high carbon steel. So this is a brittle one, a brittle. Okay, this is ductile. So the low carbon steel, it does have higher ductility compared to the high carbon steel. The middle or the medium is in between. Okay. Also another series of stress. Okay? There is something called toughness. Toughness is the total area under the stress strain curve, as we covered before. And here, small toughness. Okay, like ceramic. Ceramic is very brittle material. Okay, and large toughness. This is metal. Okay, and very small toughness. Okay, which is a very small area. So I need you to know that this is a ductile material and this is a brittle material. Okay, ductile will deform a lot. It does have larger area under the stress strain curve. Okay, so I need you to know. So a brittle fracture, okay, ductile fracture, brittle fracture is a small toughness, and larger toughness is indicating that the material is a ductile material. These series of curves are very, very important, and you understand, okay, what is meant by this. And we talked about this before, and we solved some problems. Okay, creep. What is creep? A creep is a definition that is given in most of the materials books as the deformation that will take place under constant load over time. So creep is a deformation. It's called time-dependent deformation under load. Usually, okay, measure the strain rate by the strain rate. And there is one equation given here. Nobody will ask you to memorize the equation. The equation is here. And all these parameters are given. So what is the definition of creep? Creep may be defined as a time-dependent deformation at elevated temperature under a constant load or constant stress. And we need to, okay, to understand the creep, because we consider this in concrete, we consider this in other materials, which is basically deformation. Creep is deformation under constant load over time. And we need to know that, okay? And I don't know, in your school, have you done the creep test or not? I went back in Las Cruces in New Mexico when I was teaching. I asked the student to develop this curve. And we are using lead, by the way. We are using a specimen like this, lead specimen, because lead can deform a lot in a very short time, because I have only 3 hours for the lab. I cannot use steel. So I have a piece of lead like this, lead, L-E-A-D, I believe, okay? Do you remember gamma? Gamma is a unit weight or density. Gamma water, how much is gamma water? 62.4 pound per cubic foot. We remember that? Do you remember gamma steel? Gamma steel is what? It's 490 or 91 or 92, but 490 is acceptable for a pound per cubic foot. Okay. Do you remember gamma concrete, which we're going to see today? Gamma concrete is between, for normal weight, 145 to 150 pound per cubic foot. Okay, do you remember gamma wood? We're going to see it today. Gamma wood, we have a very wide range, but you can see about 32 to 33, half of the water, about half of the water, pound per cubic foot. We need to remember these numbers, because during the exam, you may need one of these. They are listed, by the way, at the end of the mechanics of materials chapter, but If you remember them, probably will be good, especially concrete 145 to 150. This for normal weight concrete. And we're going to see another type of concrete called lightweight. Okay, what about gamma lead? Lead. Do you think lead is heavier than steel? Steel is 490. If you have 1 cubic foot of lead, pound per cubic foot, what do you think? Heavier than steel or lighter than steel? I need you to find this. What about gamma gold? If you have 1 cubic foot of gold, I know gold is very expensive nowadays, but went down. Right now it's 1800. 1800 per, yeah, 1800 per ounce. Yeah, it was yesterday 1800. Okay, pound per cubic foot. Can you find these two, by the way, for me? What is a gamma lead and gamma gold? What is, if you have 1 cubic foot of gold? Oh my God. Okay, how much this gold weighs, by the way? What about lead? Is lead heavier than normally? Try to remember things relative to each other. Water, this is any civil engineer, even while he is dying, if you ask him what is the unit weight of water, he should answer. Okay, do you remember that? Okay, okay, 62.4 at normal temperature. And remember the other stuff. Find this please for me. So what we do for the, this is the lead specimen, what I used to do back in Las Cruces in New Mexico. We have this specimen, it's about 1/8 of an inch thick, and we apply a load. So we attach this to a frame. I have a frame, wood frame. In fact, it was wood frame like this. Okay, I have a hanger. Okay, and we apply a load B. And we have 2 marks here. We make little tiny light marks with the pencil, and we measure the length at the beginning before we apply the load. And after we put the first load, we have something called initial extension. This will elongate due to this load. And after that, we start to add load, more load. So plus delta B, plus delta B. So we are adding load, okay, up to a certain limit to stop. Okay, after we add a little bit load just to accelerate it a little bit, but it's supposed to be constant load, we add a little bit, okay? Or if you like to still we stick with the B, I have no problem with that. So if you leave this under this constant load, after 10-15 minutes, this is time, and this is delta. You will find that this distance is increased more. I am here. And after that, we will find there is a stage, it's called constant stage. Here it is, where we determine the creep rate. It's called the secondary creep. So this is called the primary creep, secondary creep, and the last one, which is the last stage where it's going to fail. It will all the way. This second stage is very important because the slope of this is called the creep rate. A creep rate is the delta y, which is deformation, delta over time. Because this is time. So this curve is very, very important, and I need you to know that the creep rate, which is a slope of the linear portion, is called the creep rate, and I need you to know what the creep rate is, because we need to determine this so we can see after how many years, okay, or how long it will take from the beam to deform certain amount of deformation. So creep is important, and I need you to be aware of that. Okay, definition of creep, I put it again in front of you here. Okay, is this sorry, the creep rate. The creep rate is a linear portion, the slope, okay, which we call it the secondary creep. I need you to know these 4 portions of the creep curve. And another problem, swimming pool. Do you remember the swimming pool I mentioned? Okay, which of the following is not true about the creep rate? A creep rate is the same as a primary creep. No. Okay, a creep rate is the slope of the linear portion. Yes. A creep rate is occurring during the secondary creep. Yes. A creep rate, okay, is the unit, okay, inch per millimeter. Yes. So the only one is, and I'm asking which one is not true. Be careful on the exam, by the way. Sometimes they ask which one is true, which one is not true. TRUE, okay? So we have to be attention which one they are asking. Correct or incorrect. Also, this is another term that they use it, correct, incorrect. Okay, true or false. Instead of not true or untrue, false. All these are target for questions I need you to know But please read this, okay? As I told you, the reading is, okay, fatigue. Fatigue, in fact, for the PE, they're asking for a question, by the way. If you look to the PE, they have also the NCAAS, they have a book, has questions. And if I remember correctly, there was one question, let me bring it to you here. I think to remember, yeah, this is, for example, this is the PE. They have the NCAAS, they issue also practice exams. And I believe in the AM, there was a question. Let me see if they're still here or not. I used to have it here, or they used to have it, unless it is no longer, they have it here. Because they change these questions from time to time. Curve, horizontal, vertical. No, here it is. Here it is. Question number 133. This for the PE. But I need you to know that BE 7, okay, AM exactly as FE 7. So, for example, this is a question here. Question 133. Fatigue in steel can be the result of a reduction in strength due to cyclic loads, deformation under impact loads, deformation due to overload, and expansion due to corrosion. Obviously, the answer is A, fatigue. And we're going to see very important curves called SN curve. SN curve. I don't know if in school you determine the SN curve or not, or your professor talked about it or not, but we'll see it. What is the fatigue? Fatigue is basically, it is failure due to repeated cyclic loading. Like a piece of wire, I don't have a piece of wire, I can get a wire during the break, and if you keep bending back and forth, you will find that the piece of wire will break after a certain number of cycles. So fatigue is very important, especially for bridges. When we design bridges and we see that bridge will live for 50 years, so the trucks back and forth, and every time members will be under tension, under compression, so we need to know how many cycles are needed to cause a failure. And that's why President Biden, he has this in his stimulus package. He has the infrastructure, okay, the infrastructure for the United States, bridges and roads are really in bad shape. In fact, the ASCE, the American Society of Civil Engineers, they give a rating of C. I don't know if you read the report or not, for our bridges and roads. The bridges and roads are in very bad shape. Bridges and roads, okay. This is why they need a lot of engineers. This is, I need you to pass the FE, and after that you go and take your PE, and if you like to get the SE later on, I have no problem, but at least to get the PE, because they need a lot of engineers for the next 5 or 10 years to build all these bridges and all these roads and fix them, and we are relying on you, okay. I'm getting old and you need somebody to take care of me, okay. So you are going to be the new generation who will take care of all these bridges and all these, okay, roads, to fix it and bring it to the good state of condition, or good condition, okay, or good state of repair, as we call it. So fatigue is a phenomenon that where structures fail when subject to a cyclic loading. Okay, this type of mechanical or structure damage will occur even when very low amount of stress, but still fatigue. So imagine that this is a stress and this is time, and I have a cyclic loading. This is called the cycle. Okay, so if we keep doing this, okay, cyclic loading, the material will feel even under very small amount of stress. There is this machine, I don't know if you saw it or not in your school, it's called the beam or rotating beam machine. This is a motor that will generate the number of revolutions, and here is a specimen, and there will have some kind of counter, and we put a load. This specimen right now, under this load, is a dead load. It will do this, compression, tension. But because of the rotation, the tension side become compression and so on. So it will keep rotating, and this is another illustration. This is going to generate what is known as a fatigue, or the SN curve. The S is the stress, and N is the number of revolutions required to cause failure. And I give you a typical here SN curve, okay? And we have something called fatigue limit or endurance limit. Fatigue limit, endurance limit is defined as the level of stress at which the material will never fail even with infinite number of cycles. So it is the level of stress where the material will never fail, okay, even with infinite number of cycles. So if you lower the stress to a certain limit, you'll find this curve, okay, become horizontal, and this is called fatigue limit or endurance limit, which is a level of stress at which the material will never fail with infinite number of cycles. And I'm showing you other additional curves here, which is, here it is, fatigue limit or endurance limit. Here it is. I need you to know that. And this is actual SN curve. Because the number of cycles, by the way, large number of cycles, we're using log scale, by the way. This is a log scale. Log scale is not really a regular scale. Because the number of cycles, many number of cycles. And this is a stress. It's called SN curve. It's very important. Or SN diagram. SN diagram or SN curve. Okay, I need you to be familiar. I need to be familiar with what is endurance limit, what is fatigue, and so on. Okay, fatigue in steel resulted from. In fact, I got the same question. Okay, deformation under impact load? No. Okay, deformation due to overload? No. Okay, expansion due to temperature change? No. A reduction in the stress due cyclic loading? Yep. And this is why I select the answer D. Make sense? Easy stuff. I know you remember. You remember all these things from school, and this is just a refresher because I need to hit the most difficult part, which is concrete and mixed design, and I will explain the problem that given in the NCEES book, and hopefully I can explain it to you to understand it because it's a little bit confusing as they state the problem. Hardness is another test. Hardness. Any product when they manufacture, like even this pen, okay, it must have some kind of hardness number. When, okay, hardness basically is the resistance to scratching. Basically there are more than one definition, and we're going to see that. So hardness, relationship between hardness and tensile strength, they came up with this equation, okay, where BHN is a Brenner hardness number. Hardness is resistance to penetration measured by dentation or denting a material under a known load, okay, to cause certain size of dent. Okay. Hardenability, it is the ease with which the hardening can be, okay, obtained. Hardness is the resistance of material to deformation, indentation, or permanent, or penetration by means of such as abrasion or something like that, or impact, or drilling, or scratching, or wear and tear as we. So I need you to know the definition of hardness. So it is defined as the resistance of or resistance to deformation. Deformation could be it could be indentation, penetration by any means such as abrasion or a diamond cone or a drilling, impact, scratching, and or wear, measured by the hardness test such as the Brenner, okay, Noob test, and Rockwell and Vickers. So we have more than one. Brenner is very, and Rockwell also very, okay, very famous. Brenner hardness number, if you remember, and Rockwell and so on. So how are we going to measure hardness? They came up with the following classification: scratch, indentation, and rebound. Indentation, okay, scratch, hardness. And you remember, I think, Mohs scale. Here it is, Mohs scale. Mohs scale, M-O-H-S, okay? Okay, so the scratch hardness is a measure of how resistance of a sample is to a fracture or permanent plastic deformation due to friction from a sharp object. So basically we have a sharp object and we need to scratch the surface and see how hard the surface, and they are using, okay, the most common test is the Mohs scale, in which, okay, use mineralogy, okay, one tool is to make, okay, this is called the scratch hardness. Another type of hardness is called indentation. Indentation hardness measure the resistance of a sample to material deformation due to a constant compression load from a sharp object. And you will see on the following page the diamond that we are using. Here it is. Okay. Indentation hardness. We have, this is normally a diamond, a diamond cone like this. And we apply a load, but there are two loads, in fact, minor load and major load. The minor load is just to let this cone to penetrate into the surface, just to get rid of any scales or anything on the surface. I need this to have a firm seating on the material. After that, we'll apply the major load. So this will go down certain material, certain depth, and after that, we release the load, we keep the minor, and see how deep it is. We make this indentation as a measure for the hardness. And Rockwell test and Brenner test, those are the most common ones. However, I mentioned other names. Rebound hardness. The rebound hardness, they came up with a very nice device. They say this is the surface I need to measure the hardness. If I allow a mass M to fall from a certain height, H, as all of you know, I have something called potential energy, PE. PE stands for professional engineer, and it stands for potential energy. Potential energy is mgh. The moment I release this from rest, it will come and hit the surface. The moment I release it, became kinetic energy, which is 1/2 mv square. If we ignore the air resistance, theoretically speaking, the PE, kinetic energy, equals kinetic energy. Okay? And we're going to see this equation again in the impact in just a minute. So the rebound hardness is also known as the dynamic hardness. Okay? Measures the height of the rebound. This is going to hit and come back. We take this height here, which is H1, which is the height of the rebound, as a measure of the hardness. If this surface is very hard, it will rebound higher. If this surface is very soft or lower hardness, obviously it will not rebound. So I need you to be aware of that and read it. So which of the following is not a type of hardness? Dynamic hardness, we just mentioned dynamic hardness is a rebound. Scratch, yes. Indentation, yes. Ultimate hardness, there is no such thing. So the answer is D. There is no such thing. It's called ultimate hardness, okay? We have the indentation, we have the rebound, which is the dynamic, and we have the scratch, as all of you know, okay? So I need you to know that. And again, look which one is not. As you can see, I put here this not in a bold face, okay? But on the exam, I don't know if they're going to make it or not as a bold face, but I needed to be aware of that. Let me see here. Gold, our friend, he provided me lead. He provided me with lead. So, okay, that's fine. We will wait for a couple answers from some of you. Okay. Thank you very much, my friend. Okay. Question number 8, hardness. What is the approximate tensile strength for a carbon steel that has a Brenner hardness number of 80? As you know, they provided these equations here, which is a relationship between the tensile stress, TS, tensile stress, is equal to either in PSI or megapascal. It is 500, around 500, by the way. This is an empirical formula. So this is why you'll find that. Okay. So if this is, so the tensile strength is equal to 500, a Brenner hardness number, BHN, or in megapascal 3.5, a Brenner hardness number. I have 80 here. So 80, if you multiply 80 times 500, this will give me 40,000, which is this number here. And also if you take the 80 times the 3.5 to get it in megapascal, So 300, 240, and 280 MPa. So this is why I selected the answer C. So I calculated both ways to let you know that that's why I selected the answer C. Make sense? Everybody is awake? Good. Impact. Impact, okay? The impact test and Charby and the ISO test. If you remember this specimen here, I still have some. I have a lot of specimen, by the way, from Las Cruces, New Mexico, and from Fresno State. Okay, teaching all these materials, labs. So impact, you have a specimen, you have a V notch, and we have two types of test. This is called the ISIT, and we're going to get the other test. Okay. So impact, the Charby impact test, okay, is used to find energy required to fracture and to identify the ductile to brittle transition. So this is a curve. This is again the NCEES. Do you know which page is that? Everybody is following me, or let me see if I can locate it for you guys. Here it is. So verbatim, I copy from here as far as the, but I add more in order to explain what is the back test and all these things. So this is on page, probably in the future I can write page number, probably would be a good idea. I will add the page number here. So this is page 103 of the NCEES. So a Charby impact test is used, okay, so this is the temperature and this is the energy. You will find that as the temperature increases, okay, the curve, and after that we have the transition. So please read this. So definition of impact test. I explained it to you, the principle for impact test, and I showed you the machines on the back. The following page, this is the impact test, the Charby, where they have a pendulum. You raise it up, okay, and you lock it, and after that you put the specimen, and this pendulum will swing the moment you release it. It will hit the specimen, and you are going to take the impact directly on this. It's called the impact testing machine. So there are two types of tests. This one here is called a Charby, where you put the specimen like this. Here is a specimen that has a V notch, and you put it this way, and the pendulum will hit you from the back, opposite to the notch, to ensure. So this is a notch here, standard notch, by the way. Okay, so we buy this specimen, okay, manufactured according to ASTM, because each test, it should be done according to ASTM, the American Society for Testing and Materials. There is another test, is called the ISO test, which is this one here, where the notch, the specimen is a little bit longer, and we put it that way. We hold it here, and the pendulum will come and hit it this way. Okay, hit it. Okay, so the pendulum is coming, the impact is going, and this is a V. Okay, and we report the results, and they have some standards, and we need to compare it with the standard, the impact, and so on. So I need to know the Charby and the ISO test, and the effect of the temperature on the Charby also is very important. This, when you have a brittle behavior, and after that you have a ductile behavior, and the temperature transition. Question number 9. Impact strength is defined as the ability of the material to absorb energy, the potential energy of the pendulum, the resistance to cyclic loading, deflection under impact load. Obviously, it is the answer A. So the impact is the ability to absorb energy. This is why we put on the freeway, so as you know, when we have a median, okay, if you have a highway and you have a median, you have 3 lanes here and 3 lanes here, assuming 2 lanes, 3 lanes, this we call it median, okay, and we're going to see this in transportation, by the way. Okay, even they are still using the old code. I don't know why they are using still the highway capacity manual, the old one, 2010. So in order to provide something in the middle to prevent vehicles from crossing the median and hitting car on the opposite side, so we put something that's called a barrier, concrete barrier. Okay. Nowadays we are using concrete because it's less maintenance and different types, shapes of barriers, sloped and. But in the past we used to have wood. We put wood and we put tri-beam barrier metal. The wood is capable of absorbing a lot of energy impact. But maintenance for wood is really the reason that we switch from wood to concrete. But we put and we shape the barrier such that it should be capable of absorbing energy, the impact, because the car will hit the barrier at high speed. And they did a lot of testing and at different angles. And don't worry about that. We have a book. It's called Roadside Design, a roadside design guide, specialized in this FHWA. They developed this book for us to show us all kinds of tests at angle and height of the barrier and the shape of the barrier, and they did a lot of crash tests in order to ensure that what we are putting on the freeways is safe to the public and will minimize. So impact is very, very important, and I need you to know. So impact is defined. Impact strength is the ability of the material to absorb energy. The higher the energy, the better. Now the uh, following topic, which is concrete. On the same page, page 103, this is page 103 where the impact is. Also on page 103, you will find that they provide two curves for concrete. Here it is. Concrete, this curve here and this curve here, and that's it. A little bit of discussion here about the water cement ratio, W over C, as we're going to see, and they define workability. But you'll find that the section of this is all what they provided to you, by the way. And they included one problem, as you remember, we're going to see it shortly. So, and this is what I'm providing. This is on page 103, as I mentioned, page 103. And this is also on the same page, page 103. This is what the NCAA is. So I took all this and translate into English by explaining a lot of things, a lot, okay? If you study this, I believe you will be able to answer any question related to concrete for the FE and for the PE also, okay? So I know it is a healthy section, but you will never forget this if you understand what's going on here, and you will be extremely happy. After that, we have wood, a little bit of wood discussion, and after that asphalt testing. Also I provide a lot of testing here, and soils and asphalt, and the last section is a problem related to thermal properties, okay? And this is the end of the materials section where we have 49 problems, okay, with different topics and different. So let's take a few minutes break, stretch your back, and I need to stretch my back too. So right now is about 10:10. So 10:20, come back with open mind and open heart to continue our discussion. And we're going to start with the concrete, which is very important topic because they are providing very limited amount of information, but I will do my best to explain it to you guys. And I'm sure that after you finish this, that you will be happy and you will be able to answer the questions related to concrete, unreinforced and reinforced. Okay, and we're going to talk about this. Okay, so after 10 minutes from now, let us meet. Thank you very much. Okay, welcome back everybody after this short break. So the following topic in front of us here is concrete. When you are sending these questions to study, what are the questions you are talking about? The questions, the chapter I'm talking about in front of you already was sent to you, all of you. If you did not receive it, email me. I'll be glad to send it to you. This number one. Number two, if you are talking about this material in front of you here, it has been sent before. Okay. As far as the questions or the practice problems or the one I was referring to at the beginning of the homework, also it has been sent to everybody. So if you attended the class before, basically I took all the names from the attendance sheet and send it to everybody. If you are missing any of them, email me and I will be glad to send it to you if this is your question. Okay. When you are sending these questions to study, these questions are there in the chapter, and you're supposed to have the chapter and you're supposed to print it and you're supposed to follow me until one day I will assemble all these 9 chapters and I'll be glad to send it to you when they are ready. I will mail it to you for free, but when I assemble all the 9 chapters together. Okay. So bear with me. If you are in a hurry and you're going to take the exam very soon, search the market full of books. You can buy any books you are interested in. And I will be glad to help you with any topic or any subtopic from any other books, because I have all the books available in the market. I have it, but I prefer to use my own. Or hopefully the one day I will finish it. But if you are going to take the exam very soon, before I finish, you can go and also there are many courses available in the market, by the way, many courses. Okay, some of them are free, some of them they charge money. You are very welcome to search the net, and the net full of many things. If anything I can help you with, please let me know. Okay. No problem. All the ultimate goal is to pass the exam, take it and pass it, and that's it. Okay, it doesn't matter which material you are using, mine or somebody else, which course you are taking, mine or somebody else. This is your choice. It's not my choice. It's your choice. I'm here to help as much as I can, and um, okay. Sorry, I responded to somebody asking for a seismic class CV, seismic cluster. Concrete. If you look to the NCEES on page 103. You will find they provide this curve, which is very famous curve, which is W over C, which is water over cement. And this by weight, the ratio to the water to the cement by weight. And this is the 28-day compressive strength. And they have two curves here, or two, no added air and recommended percentage of the entrained air. And they define what is the water cement ratio is a primary factor affecting the strength of the concrete. The figure above shows how water cement ratio expressed as a ratio of the weight of water to the weight of the cement, how this affects the strength for air and non-air. If you look to the concrete in general, concrete, you will find concrete can be classified to many different types of classifications, or we have different types of concrete. So if you put concrete here in the center, so concrete may be defined or may be classified, much better word, classified to be air entrained, air entrained, and non-air entrained. This is the first classification, and we'll see the difference between them. Concrete could be either normal weight or it could be lightweight. And we are going to see the difference between them. Concrete could be classified as a plain concrete plain, or it could be reinforced. Reinforced. And reinforced concrete could be either the regular reinforcement, or it could be pre-stressed. And the pre-stressed concrete, there are two types: a pre-tensioning and post-tensioning. Pre-tensioning and post-tensioning. So this is the overall picture of concrete. Either air entrained, the one that we are adding some admixtures to create some air, or non-air entrained. This is one classification I needed to be aware of. Or it could be normal weight or lightweight. Or it could be plain or reinforced. The reinforced could be regular reinforcement, which is the rebars, or it could be pre-stressed. And we'll see the difference between the pre-stressed concrete and reinforced concrete. We need to understand the difference between all these types of concrete, because you might be asked about this. If we take the first one, which the first two groups here, air and non-air. And the chapter I'm providing you is a very, very healthy chapter, and it does have a lot of information. As I mentioned that, please read as much as you can, and the more you read, the more you will be familiar. And I believe if you understand all the material I provided here, you will be in very good shape. I cannot guarantee, because my lawyer always advised me don't use word guarantee. One time I was telling him about something, and I was guarantee. So, Dr. Mansour, don't use the word guarantee. They say probably, maybe, most likely. So most likely you will be able to answer any question on the exam. I cannot guarantee anything. So, any concrete exists on Earth, it has four basic ingredients. So any concrete exists on Earth, it doesn't matter what type is. It does have the fine aggregate, which is sand, plus the coarse aggregate, which is the gravel, plus water, plus cement. Those are the four basic ingredients of any concrete exists on Earth. 1, 2, 3, and 4. We add something in addition to these four basic ingredients. Sometimes we call them additive, and sometimes we call them admixtures. So additive, admixtures, and we're going to see them later on. Additives or admixtures. Those are other than the four basic ingredients. The additives or the admixtures are added to enhance or improve the properties of the concrete, either during mixing, or during placing, or during finishing, or after the concrete hardened during the service life of the concrete. But they are using letter W for water, and they are using letter C for cement. This ratio, which is water over cement, is called water-cement ratio. This is the most important ratio that will affect the strength and the cost. And the water cement ratio is by weight, not by volume, because we are going to see one equation. We are going to use it to convert weight to volume and volume to weight. This equation is called absolute volume equation. Absolute volume. They did not give you the equation because the equation given in the soils section. I will show it to you. The volume is equal weight divided by, this is weight by the way, not water, weight, and this is volume. Divided, not speed, volume, divided by gamma of the water times specific gravity of the material. This is the equation. It's called absolute volume equation. Very important equation. And this is came from the definition of SG. What is SG, by the way? SG, or some book they call it GS. I believe in the NCAA they are using SG. This is called specific gravity. Specific gravity. What's specific gravity? Specific gravity is the ratio between two things. Gamma material over gamma water. The unit weight of the material over the unit weight of water. This is why you are saying that what is the specific gravity of water is 1. Because gamma water over gamma water is 1. But steel, for example, gamma steel over gamma water, this will give you the specific gravity for the steel, which is 490 over 62.4, and so on. Any material that will sink in the water has a specific gravity greater than 1. Any material that will float on the surface of the water has a specific gravity less than 1, like wood has specific gravity of 0.5, for example. But aggregate, probably, okay, 2.6, 2.7, and so on. So this equation, absolute volume equation, came from this. Specific gravity is equal gamma over gamma. But what's gamma? Gamma is equal weight over volume. And this is gamma water. If you solve for the volume, you'll get this equation. So I needed to remember this equation because this equation in the soils section, and we need it in order to solve the concrete mix design problem. It's called the absolute volume equation. Okay, I need you to remember this equation. The volume is equal the weight divided by gamma water divided by the specific gravity. So if you look to these 4 basic ingredients of any concrete mix exist on earth, the fine aggregate, which is the sand, the coarse aggregate, which is the gravel, like this piece of gravel here is crushed. It could be natural gravel or crushed gravel, like sand also. It could be natural or it should be crushed. And the water, it should be potable water. And cement, we have 5 types of cement. 5 types, and we're going to see the 5 types. Each type has a use. If you look to this water cement ratio versus the strength, and this is a curve that's given in the NCAA. So here it is. They give it as a straight line. I have no problem with that, but it is better to express as a curve because the exact relation is curve. So if this is a water over cement, this is ratio by weight. Again, by weight. This is how many pounds of water over how many pounds of cement. Or sometimes they express the water cement ratio, by the way, how many gallons of water over how many sacks of cement or per sack of cement. A sack of cement, as all of you know, weighs 94 pounds. Any sack of cement in the United States is just only 94 pounds. They decided 94 pounds because it's a volume of 1 cubic foot, not because it's lighter than 100. I asked us, probably I told you this before, I was asking engineer, why they made it 94 pounds? Oh, it's easier to carry, Dr. Mansour. Oh, I can make it 100 pounds, much easier, my friend, to remember, and 6 pounds is not a big deal, but this is a volume of 1 cubic foot. How many gallons of water Okay, because we know how many pounds in 1 gallon of water. 1 gallon of water, as all of you know, gallon of water weighs what? 8.34 pounds. Any gallon of water, if you weigh it, you can, when you go to the grocery store today, or when you go to buy milk for your family or yourself, just grab a gallon of milk and weigh it to see how much it weighs. And tell me next week, it's heavier than water or lighter than water. Grab a gallon of milk, okay? And you can estimate the empty plastic, okay, container, how much it weighs. But just grab a gallon and put it on the scale in a grocery store and tell me next week, 1 gallon of milk is heavier than water or lighter than water. 1 gallon of water weighs 8.34 pounds. So if you look to the water cement ratio, and this is normally start about 0.2 here to about 0.7. This is a common range. Very low water cement ratio, very high water cement ratio. And this is the strength, which is call it F sub C prime, or the 28-day compressive strength. When we prepare concrete cylinders, we are going to see it. Already I showed you before. The 6 by 12 standard size, or 4 by 8, and we crush it up to failure. This is called the compressive test or compression test. Okay. So if you look to the two curves that they are given in the NCEES, one for air entrained and one for non-air entrained. So there is one curve like this. They put a straight line. I have no problem. This is for the non-air, which is a curve. Here it is. No added air, this one here. They carry curve all the way to 1. We never reach this. It is between 0.2 to 0.7, 0.8 even, but he gave you just theoretical curve. No problem with that. Because ratio 1 means that 1 part of cement to the 1 part of water will be very harsh mix, and you cannot really. The second curve, this non-air entrained, non-air entrained, and I will tell you why we do that. The second curve is air entrained. This is air entrained, where we are adding some admixtures to create air. Here it is, recommended percentage entrained air, which is this one here. This is the blue one, entrained air. And I will show you the recommended percentage, what he's talking about. It's very weak, very, very concise presentation of this, but will. So for any given water cement ratio, any like 0.4 or 0.5 or 0.6 or 0.5, if you come and draw a vertical at any given water cement ratio 0.5, you will find that this is going to intercept the two curves. The air entrained will give you a lower strength compared to non-air. So the strength is increasing this way, by the way. This probably 4,000, this 5,000 PSI, as indicated on the curve here. either megapascal or PSI. Here it is, 2000, 4000, 6000, 8000, 1000. So the strength is increasing this way, which is a 28-day compressive strength. This came from the cylinder test, the compression test. P, and we remember from mechanics of materials, P over A, which is basically the F sub C prime. Okay? So, as the water-cement ratio increases, means that I have more water than cement. Concrete becomes weaker. At lower water-cement ratio, means that less water compared to the cement. So, this blue curve, which is air entrained, will give you a lower strength for any given water-cement ratio. But what in return we are gaining from this? We are gaining something is called durability. The term durability is very important, and you will see it. I explain it very well. Durability, which is the resistance to load and specifically environmental conditions, like in snow areas, something called the freezing and thawing. So we are adding chemicals to create air bubbles. The air entrained concrete, it's concrete. It has the four basic ingredients, the coarse and the fine and the cement and the water, but we are adding some admixtures to create air bubbles. Air bubbles is called air entraining admixture to increase the durability. So we need to improve the durability, improve or increase the durability of concrete. The durability, resistance of what? Number one, environmental conditions, especially freezing. Environmental conditions like freezing, so the concrete will not crack, and also to resist load, wear and tear. So it does increase a little bit of the load resistance, but mainly it is for this. Mainly for this, to increase the resistance to freezing and thawing. So this is a curve that I needed to be aware of. So the non-air entrained will give you a higher strength for any given water-cement ratio, but will not be suitable for northern states where they have a lot of snow and a lot of ice. Okay, so this is what I need you to read and to know, because this is what you are going to see only on the NCEES. So concrete strength decreases with the increased water-cement ratio for concrete with and without air entrance. So as the water-cement ratio increases, the strengths go down. As you can see, the curve is coming down. I need you to know that. The other thing, here it is, water-cement ratio is a primary factor affecting the strength of the concrete. The figure above shows the how water-cement ratio expressed as a ratio of the weight of water and cement by weight of the concrete mix affect the compressive strength of both air entrained and non-air entrained. This is the first curve I needed to be aware. The second curve, the NCEES, they provided on page 103 of the NCEES, the 10.0 edition reference book. Is the age of the concrete, time, and the compressive strength in PSI. And the title of this curve or series of curves concrete compressive strength varies with moist curing condition. Mixes tested had a water cement ratio of 0.5, a slum of 3.5 inches. We'll see what slum is. Cement content of 556 pound per cubic yard, and sand content 36%, and air of about 4%. They did a lot of cylinders and they tested for this kind of concrete water cement ratio, and you will find series of curves. And the first one, which is stored continuously in the air, in the laboratory in the air. So they mix it, and here the number of days, 037, 28 days. This is very important, 28 days. You see the strength will grow and it will stay almost constant, drop a little bit with age. But if you keep the concrete moist, okay, and you put it in the air after 3 days, so the concrete will increase the strength, but after that, in the air after 7 days, and in the air after 14 days, and continuously moist, which is a solid one, which is a very important one. And I will tell you why this is all this. If you look to the solid one, continuous moist, here it is, this one. The solid one. If you keep the concrete moist as long as you can, you're always gaining strength. But obviously in life, we don't do that. We stop at 28 days, by the way. The 28 days is a criteria that they decided to use after 28 days. So the 28-day compressive strength is a criteria. It's mentioned more than once. Compressive strength, 28 days here. Okay, if you look to the upper curve, you'll find 28-day compressive strength is the number that they agreed upon. And not because 28 days after 4 weeks. So if you mix in on Saturday or Friday or Monday, you will come back after 4 weeks Monday, so you'll not come on the weekend. Like the joke probably heard, why they make it 28 days, so you'll not come on the weekends. No, but if you mix concrete on the weekends, you have to come on the weekends. But not all of us work on the weekends. But the reason that the 28 days was selected because the dead load and the life load, this is what that criteria plus the strength of the concrete. So they found that the 28 days is the time that the concrete will achieve its strength, and it will be capable of resisting whatever dead load and life load applied to the structure. So it is related to the strength. It's not because we are not interested to come on the weekend or the weekends to work. Okay, today is a weekend and we are working. Why? Because you are looking for the PE. Do you remember the FE first? And you are looking for the PE. You left the couch this morning and you probably sacrificed. Sorry, today is Sunday. Normally, I don't like to teach on Sunday because everybody wants to go and pray to God. They probably go to the church. If you go, please pray for me, and I'll pray for you when I go to the mosque. Okay, so don't worry. It will be mutual. Okay, mutual. Okay, prayer. You pray for me, I pray for you. Okay, for free. Don't charge me. Okay, and because I will not charge you. Okay, so 28 days. I need to remember that. Okay. You look to what is written here. It says that water content affects workability. What is workability? Durability, workability. We're going to see that. Workability. Workability is the ability of mixing, transporting, placing the concrete and finishing it with the minimum amount of work or a minimum amount of labor force. How easy the concrete can be mixed, placed, and finished. It's called workability. And there are two tests we are going to see it related to the workability. So workability There are two tests. We're going to talk about the slump test and the Kelly ball workability, and you will find a lot of discussion in my book about so the longer that we keep the concrete moist, the higher the strength. But the criteria is the 28 days. So they did all these tests in order to indicate if you mix concrete and leave it in the air without putting any moist or moisture, it will give you this strength. If you store it in in water or moist, and after 3 days you take it out and put it after 7 days and so on. But if you are continuously keep it moist, the strength will keep gaining. Because of what? There is a term I need you to know in addition to workability, and the term durability. All these terms are mentioned in the book. Okay? There is something is called hydration. What is hydration? Hydration is defined as a chemical reaction between water and cement. Chemical reaction between water and cement. This chemical reaction will continue as long as you keep the concrete moist. And the higher the hydration, the higher the strength of the concrete, or the completeness of the hydration produces much better word. This is what I meant, okay? If you allow the hydration to take place and to be completed, obviously you are getting higher strength. So this is the second curve I need you to be aware of. So workability. However, an increase in water without corresponding increase in the cement reduces the strength. We know that because water cement ratio. Super plasticizer are the most typical way to increase workability. Air entraining is used to improve durability. The term durability is mentioned here. Workability. Air entrainment. Super plasticizer, which is admixtures. Super plasticizers. All these language or all these terms, you should be familiar, and all of them are spelled out completely in my book, in my chapter here. I explain it very, very well, okay, because I teach this for the PE for a long, long time, and I have many books, so I extracted what I believe that you need from this section. This is what the NCEES provided. Now look to what Dr. Mansour provided, okay? Provided a lot of discussion, a lot of definitions, a lot of terms, a lot of equations, and we will cover as much as we can. But let me grab a question from one of you and see what is the question. Okay, thank you. Deal. Okay, deal. Okay. My friend is telling me we'll pray for you and you pray for us. No, no problem. Deal. I have no problem. I have no problem. Okay. So the reading, obviously you promised me that you are going to read. And I start here introduction and definition, sorry. A fresh concrete, where the concrete is fresh, we do a test like workability, either the slum or the Kelly ball, unit weight, temperature. And we also sometimes we determine, by the way, the air content. And I'm sure that you did this in the lab. Okay, air content, there are two methods, by the way. One is called the volumetric method, and one is called the pressure method. Because we know the air, amount of the air of the concrete in the concrete is very important. So they came up with these tests in order to tell us how to do the air content using the volumetric method or the pressure method. Why we are doing these tests for concrete while still fresh? Fresh means still not hardened. In order to determine the method of construction, how we are going to transport the concrete and finishing methods and techniques. But after the concrete hardens, we need to do the compressive strength, which is F sub C prime, which is P over A. We are going to do something smooth of rupture, which is the beam test, which is came from MC over I. And we're going to do what's known as splitting tensile strength, which is F sub CT, which is 2P over pi dl. There's one equation, it's called the Brazilian test. And you'll find all these equations. Durability and water tightness. Water tightness is very important for canals and storage tanks, water tanks. I need the concrete to be watertight. I don't like the concrete, okay, to be, okay, seeping the water, or the water will go through the walls and the canals or the tanks will lose water, and we don't like to lose water. It's very, very expensive commodity nowadays. You'll find that the next war, by the way, in the Middle East, they are talking about that, is not the war for the oil, is the water, is a war for the water. Because water became very expensive, by the way. In certain locations, the cost of water more than the cost of gas, by the way. 1 gallon of water is more expensive than the gallon of gas. So water is very, very important. And they are expecting there will be in the future some wars, because not because for oil, but because for the water. Okay? So, the series of definitions, before I go, so I need you to know that. I need to know, because sometimes they ask this type of question: which of the following tests can be carried out while the concrete is still fresh? You need to know what test that can be performed or can be done for freshly mixed concrete, and what kind of tests that can be done for hardened concrete. Okay? You need to differentiate, because they ask you these questions. And if you decided to watch the movies, that the one I will going to send it to you, just all what you need, you don't have to go to the movie theater. Okay, this is a free movie from Dr. Mansour. You are going to buy a couple bags of popcorn, put it in the microwave, and that's it. And you put the movie and watch it, concrete and steel and soils, okay, and surveying, and enjoy your movie. And this movie will help you to prepare for the exam. This is in addition to the enjoyment, you will be ready for the exam. Okay? So if you look to the definitions, what is an admixture is aggregate, specific gravity. There is a term called the bleeding, by the way, bleeding, water gain, bleeding. Okay, a bleeding, we're going to see this term, by the way, in the asphalt and in concrete. In concrete, when the water migrates, okay, to the surface, okay, so some of the, this is a form of segregation. We're going to see segregation term also, where the water tends to the surface of the freshly concrete. When you pour the concrete, if this is a slab, you'll find that the water migrates or go to the surface. The problem with that, the water will evaporate. Okay, now I need to keep the water into the mix. And segregation, by the way, this is a separation of the coarse and fine. We need to have a homogeneous mix. Cement factor, how many sacks of cement? Like, for example, when we say 6 sack mix, we know a sack of cement, how much it weighs? 94 pounds, not 100 pounds. A curing time, how long we're supposed to keep the concrete cured? Okay. A dry eroded unit weight. A durability, the term durability, here it is. A durability is the ability of the concrete in the hardened state to resist deterioration from environment or the service, the load. The durability, the concrete must be durable, mean that will not crack or start to spoil or start to have some pieces out. Some pieces will start to come out. All these terminologies or definitions are very, very important. Finest modulus FM, not the FM radio. Finest modulus is, we're going to see it, how we determine the finest modulus for sand. Okay? Hydration, do you remember the term hydration? Is a chemical reaction between the water and cement. Here it is. Mix design. SSD, Oh my God, SSD. SSD in this course, we have two of them. SSD. I showed you one in the morning. SSD in this chapter is called surface dry condition. Surface dry, saturated surface dry. Saturated surface dry, SS. Let me write it down completely. Saturated surface dry or unsurface dry, SSD. Mean that the aggregate, either fine or coarse, is saturated but is dry. And I will tell you how they determine this in the lab, because I did all these things back when I was doing my PhD and my research, and when I was teaching also, I asked the student to do that. Saturated surface dry, saturated surface dry, SSD. If you look to the definition as given in the chapter I provided, saturated surface dry condition. This is no free or surface moisture on the particles, but all voids are filled with water. And the SSD only, this is for coarse aggregate and for fine aggregate. Only we apply the SSD to the two types of aggregate, the sand and the gravel. So the SSD, it does not apply to water or cement. I need you to know that. The second SSD, by the way, the one I showed you this morning, SSD, is called stopping site distance. Stopping site distance, which is SSD is equal 1.47 VT plus the V square over, I will write the form, the 30 here, 30A, plus or minus G. This is equation that we're going to see it. But they put the A, by the way, as a function of the F, the coefficient of friction, and the G. Let me show you the equation I showed you this morning when I talked about the transportation and the way they arrange it. Here it is. This is the equation, SSD. But SSD here, this is the stopping site distance, is equal 1.47 VT, V squared. Did I put V squared or just V? Yeah, V squared, that's good. Divided by 30 A over G. Let me put it as A over G, exactly as they put it. Is T or not? A over G, where G is a gravity acceleration, a plus or minus another G. This G here is a grade. G, where is the grade? It is centigrade. And we are going to see that. Where uphill is positive, G, like the stock market on Friday, it went up. Is this correct? Stock market went up, yes. Okay. Do you think the stock market will go down tomorrow or will it stay up? If the G is down, like the stock market on Thursday and Wednesday and Thursday were down, but I believe Friday will. So the stock market is up, positive. If the G is down, is negative. This is why they put a plus or minus. This is called SSD. We are going to see it in the transportation section next week, next Saturday. Okay, and I will do all my best, as I said, to feed you this chapter. So here, the SSD is called saturated surface dry. What does it mean, saturated surface dry? Because if you look to the NCEES, do you remember the NCEES, the questions I showed you? The FE book, I don't know if you bought it or not. I highly recommend you to buy this one directly from them. We don't sell it. Okay? We still have some copies of the old one, but the new one I did not order because I don't need headache to sell it. Buy it directly. I know they sell it too expensive, but what can we do? I used to buy it from them and they give me a huge discount and a best discount to the engineers, but I don't have a staff to help me, so I stopped doing that because I am by myself here. So FE7, the NCEES, you can buy it from them. And there is one problem, and this is a problem number 40. And you will find the SSD is here. Problem number 40, the following preliminary concrete mix design. Mix has been designed assuming that the aggregates are in the oven dry condition. However, the aggregate uses are in the SSD condition. It's a little bit confusing statement. I don't agree with that, but water is given, cement is given, coarse aggregate and fine aggregate, and he gave you the properties and he would like to get the amount of water. I will show you that after I correct the statement a little bit, and you will see a lot of problems, but I will explain it to you at least to understand the concept. Okay, so SSD in this contest here, or in this section here, is the saturated surface dry condition, SSD. And if you look to the water cement ratio, I need you to know the water cement ratio is the ratio by weight. Gallons of water, sacks of cement. And we know 1 sack of cement is 94, and a gallon of water is 8.34 pounds. And you are going to verify, okay, per gallon of water. Verify it again as a gallon of milk. Workability. Workability. What's workability? Workability is property that determine the effect. Workability. So workability require effort to transport a place, finish it without segregation. Segregation is here, by the way. Segregation is a settlement of the, as you know, we have 4 basic ingredients. Here are the 4. The fine aggregate, which is the sand, the coarse, which is the gravel, and the cement and the water. So if you do have a concrete mix and the coarse aggregate went down, settled at the bottom of the form or bottom of the member, this is called segregation. Segregation is bad, even in concrete. Okay, the fine and the cement and the water will be, this is not desirable or not, okay. Segregation, which is a separation of the coarse aggregate, and we need to have the coarse aggregate to its spread to carry the load. So it is the separation of the constituent. Here we go. Excuse me. So all these definitions. Here I took the ingredients, and I start to talk about each one of them and what you need to know. So I need you to read this. For example, what is the water cement based? When you mix the water with the cement, it's called cement based. The cement base has 3 functions. Here they are, 1, 2, 3. I talked about the fine aggregate, which is the sand. I talked about the finest modulus, okay, and ESTMC 33. All these things, I need you to read it. Here are the 5 types of cement. Any civil engineer, even while he is dying, if you ask him about the 5 types of cement, I need you to understand that. Okay, type 1, which is for general use. Type 1. Type 2, this is modified cement. To do what? To used when you have moderate sulfate action or moderate heat of hydration. When the concrete or when the cement and the water react together, hydration, it will generate heat. So we use type 2 of cement, where you have moderate sulfate action, or sulfate resistance, sorry, and moderate heat of hydration. High early strength, which is a fast setting concrete, the one we use it for highways. You need to fix the highway, panel replacement, and you need to open the traffic to the traffic next day. So So we are using high airless strength for the fast setting. Low heat of hydration type 4, like dams. We use it for dams, retaining walls, like, because of the heat. If you remember the story, probably I told you about it, about Hoover Dam. If you go and visit Hoover Dam, they will show you a movie when they built it in the 30s, 1932 or 31, I believe, Hoover Dam. They built a factory next to it to produce ice, to add ice to the mixing concrete because of the heat. And finally, type number 5, sulfate resistance. When the soil has a lot of sulfate and we need the concrete to resist, so we use type 5. So these 5 types, I need you to know that. I need you to know the difference between type 1 and 2 and 3, because this could be a target for a question. For example, if you remember this morning, I showed you the problem for the PE. Let me see if it's still the book here. Yeah, the book is still here. For the PE, okay, we answer one question about fatigue. Do you remember fatigue? Okay, I believe there is another question, the same page. Here it is. So this is the question number 133. Question number 132 of the PE, or from the PE. Here it is. A Department of Transportation must remove and replace 12 by 20, 12 feet by 20 feet slab, concrete slab, on an interstate facility. To minimize disruption of the traffic, the work must be completed during an 8-hour shift, night shift. Nighttime temperature was around 50 Fahrenheit. If the minimum required compressive strength is 3,500 psi, and the concrete mix that will be selected most likely consists of, and they give you 4 choices. Here it is. I will give you 22 seconds to answer this question. You should be able to answer it. After the discussion we just finished, or based on the discussion we just finished, you should be answered. Either answer A or B or C or D. Okay? So if you look to these 4 answers, so first of all, we need to make sure that the temperature is, and I'll talk about temperature later on, because concrete should be placed within certain temperature, not too cold, not too hot, and we'll see why. And I have a discussion in my book. The need also that we need to minimize, that means nighttime work shift. So 8 hours, and we need to open the interstate again, or the facility again, to the public. I need fast setting concrete or high airless strength. So he's giving you coarse aggregate, sand, type 2 cement, chemical accelerator. Do we have water here? No, this is not concrete. Remember, the concrete has 4 basic ingredients: the coarse aggregate, the fine aggregate, a plus cement, a plus water. Any kind of cement based on the use. Those are the 4 basic ingredients. Any concrete exists on earth must have these 4. If he doesn't have these 4, that means it's not concrete. Something else. Call it banana, call it whatever it is. But it's not concrete. So this is not concrete. The second one, sand, type 3 cement, water, chemical. This is not concrete. Missing sand is a fine. Where is the coarse aggregate? It's not here. So this not concrete, this not concrete. Call it this banana, this apple. Okay, my God. Okay. Coarse aggregate sand, yes, so far. Type 5 cement, that's here type of cement. Water is here. So up to here, I'm doing fine. This is concrete. But he's using type 5 cement. And he said that chemical accelerator. Chemical accelerator, this is admixture to accelerate the strength. I need it. But type 5 will not help me. Type 5 for the heat. Do you remember the type 5? Sorry, for sulfate. It does have high sulfate resistance. I don't need that. Type answer D is concrete also because it has coarse and fine. Type 3, yes, will help me. Water is part and chemical, so the answer is D. I needed to read all these 4 answers in any question in the future for the PE or for the FE. Read all the 4 possible answers they provided to you, and we are picking the best. Some answers, it does not make any sense. For example, answer A and B is not concrete, my friends. Call it something else because it's missing one of the 4 basic ingredients exist that must exist in the concrete. I needed to be aware of that. Okay, so I have questions, by the way, like question 712. The type of cement that should be selected for construction of foundation expose heavy sulfate. This is a type 5. Heavy sulfate type 5, and here it is. And I had a lot of questions related to this. A lot of stuff I needed to be aware of. This is the effect of the air, by the way, air entering and mixture. I provided you a table. In fact, I did not provide this for the PE. In the future, I will include for the PE. The effect of the air. When you put air, this is the main objective, to increase durability. But the unit weight, no change to some change. Workability will improve a lot. Segregation will be reduced. Bleeding will be reduced. The strength will go down. We will lose the strength because weak concrete due to the air bubbles. You are creating air bubbles. So I talked about all the air bubbles and all the things. Talking about the size. The most important thing right now is mixing. Slum test. I have a lot of mixing concrete. If I jump all the way to page 31 of this chapter that I want to send to you, let me finish this before I hit 12 o'clock because I need to take about 5 or 10 minutes rest before I start the second session, which is the surveying for the surveying group. There are 2 methods of mixing concrete, and this is table 7-8 of my handout. One old method that my grandfather and your grandfather used to have, which is called the weight method or the volume method. Normally we use the weight. This is a proportion method. We proportion the mix based on a ratio is given like this. The first is always referred to the cement, first number. The second number is referring to the fine, and the third number is referring to the coarse. So when you say 1 to 2 to 4, 1 part cement, 2 parts fine, and 4 parts for the coarse. This is the oldest method of a proportion concrete. Your grandfather and my grandfather used it for sure. And based on the ratio of the cement, fine and coarse. The ratio could be either weight or volume, but the weight is the most common one. Weight is the most common one. Volume is time consuming and a little bit confusing, so they decided to go with the weight. So that means that 1 pound of cement, 2 pounds of fine, and 4 pounds of coarse. And here it is. This is the old method. The current method that they use it in the ready mix plant is called the absolute volume. And the absolute volume equation, by the way, it is coming on the following page, if I'm not mistaken. Yeah, here it is. Equation 7.7. This is the volume is equal the weight divided by gamma water times, oops, times, not plus, times specific gravity. The equation I derived for you. It's called absolute volume equation. Very, very important equation that it came from the definition of the specific gravity. Okay. Thank you. The mixing concrete is based on something we call it SSD, which is this here, this condition, saturated and surface dry condition, where the aggregates are saturated with the water, all the inside holes or pores filled with water, but the surface is dry. It's called SSD. It's very, very important. It's not the stopping side distance, no. It's called SSD, saturated and surface dry condition. If the aggregates, or as I told you, the SSD applied to what? Applied to fine and the coarse only. It has nothing to do with the cement, or the cement has nothing to do with the SSD. The water has nothing to do with this. The water will change, but we don't adjust the water. We adjust the water at the end to get the same amount water cement ratio. But when we do the adjustment, we adjust the fine and the coarse, and consequently the water will be adjusted too. But the cement will never touch the cement. If you are below the SSD, we call it dry. This is the dry, either air dry or oven dry. This is oven and this is air. So this is the dry condition. The other side is a moist or wet. So if you are above the SSD is a moist, if below the SSD is a dry. So if you do have a piece of aggregate like this, how we determine the SSD? We put this piece of aggregate with the rest of the sample. We put it in a bucket of water over 24 hours. And after that, we take each piece and we dry it with nice clean towel to dry the surface completely, such that the surface will be dry. And we weigh it. So over 24 hours, it has absorbed all the water inside. After we dry the surface, we weigh it. And after that, we'll put it in the oven for 24 hours to get all the water out. And we can weigh the difference, take the difference between the weight before and after, see how much water was absorbed to reach SSD. This is how we determine in the lab. And if you did it, that's good. If not, this is how we do it. This diagram is very, very important. And I discussed it with the PE before many, many times. And I need to discuss it with you because we need it twice. We need this relationship in mixing concrete, and we need it when we are talking about earthwork. So this is the SSD, and this is the ideal condition. The SSD. If you are below the SSD, you are in the dry condition, either air or oven dry. If you are above the SSD, you are in the moist / wet. I need you to be aware of this relationship. If from here to here, from a dry to the SSD, we call it SSD moisture content. And from here to here is the moisture content, which is the total moisture content. So this is the relationship between the three status of the aggregates, the fine and the coarse. Either it could be dry, or it could be SSD, or it could be moist or wet. Okay. This is called the moisture content. By the way, we are going to see it, by the way, as W, lowercase w. And lowercase w is given, by the way, in the 7 section. Let me show it to you. When we're talking about the geotech, which is also a healthy chapter, a lot of material, and here it is. You'll find that the moisture content, which is given here, it is water content, here it is. This is on page, by the way, page 258. It is like an omega, but it's supposed to be W like this. I don't know, they type it as a little bit like an omega, like angular velocity, the one we use it in dynamics. But for some reason, but this is called water content or moisture content. So water content is the weight of water over the weight of the solid times 100. Very important relation. Also, we're going to see this is on page 258 of the NCEES under the geotechnical section, which you are going to see it. Geotechnical. So when we are doing our mix design, we are assuming first of all that the aggregates are in the SSD. Normally, aggregates will never exist in the SSD condition. So we need to make an adjustment. It's called surface water adjustment. And this is the most difficult part, surface water adjustment. Surface water adjustment is very easy if you understand it very well. And they are based on equations. These equations, I came up with these equations, which is they are available also in Lindbergh book. There is a book by Mr. Lindbergh. I wrote 5 chapters for him way back in 1995. And they are still in use, in very thick book by PPI. You can figure out these equations from this diagram. By the way, this diagram is here. The diagram I just drew, this is the SSD condition. And this is the dry condition, either oven or air. And this is the moist or wet or damp. To move from one to another, we are following this. So this is the moisture content. And from here to here is SSD moisture content. If we understand this, we can handle any concrete mix design problem. When you are at the SSD condition, no adjustment is required. I came up with this table. Here it is. This is my table here. This is SSD. This is the ideal condition. No adjustment for surface water. This is the ideal condition. This is the best. If you are above, you are in the moist or the wet. You have to adjust the water. And if you are below the SSD, you are on the dry side, either oven or air dry. So we need to know how to adjust it from here to here, or from here to here. Because I need to bring everything to here to keep the water cement ratio. By the way, the moisture content on the water content, I was talking about water content, is given by this equation, which is the weight of water over weight of solids. Here it is. So, unfortunately, these equations are not given to you. But as I told you, you can derive it from this. And also, this is not given to you. Okay, and they are asking you to solve the problem that they gave, and I will explain it to you, but I need you to understand a couple problems first. This is the problem 726 in my book, or in the chapter I gave you. Here I'm asking what is the water cement ratio, water content to the water cement ratio, which is called water cement ratio. How many gallons per sack of cement? So I need to get W over C. As I told you, the water cement ratio is by weight. Either how many pounds of the water to how many pounds of cement, or how many gallons of water, I'm repeating these things again, to how many sacks, or per sack. Normally we use 1 sack of cement as a criteria. But we need to understand what is given, like the NCEES, the FE7 NCEES problem. Let me bring it one more time, the one I showed to you. Let me see, let me. This problem here, the one I showed you, problem number 40. He said that the amount of water that was added pound per cubic yard, not everything per cubic yard, by the way, we're using unit volume 1 cubic yard. So he said that assuming that the aggregates are oven dry, and however the aggregate used are in the SSD condition, and he give you the amount of the water that's added, the amount of the cement that is added, the coarse aggregate in the SSD condition is added, how many pounds per cubic yard, and the fine aggregate. The aggregate, the coarse aggregate and the fine aggregate, the moisture content at the SSD is 0.5 and 0.7, and the moisture content as used in the mix 2% and 6%. What's the difference between this and this? Moisture content at SSD and moisture content as used in the mix. As I told you that we have the SSD condition here, and this is wet, and this is the dry. If the aggregate is dry, the coarse aggregate needs 0.5% of its own weight to reach SSD. This is for the coarse aggregate. The fine aggregate 0.7, that the aggregate need 0.7% of its own dry weight. This is a fine aggregate. This is what is meant. So the 0.5 and 0.7, those are the percentage of the moisture to bring the aggregates from the dry condition to the SSD, which is the same graph I showed you here, by the way, or the one I wrote here. Here it is. This is the SSD moisture content. So when the aggregates are dry, how much water it will absorb to reach here? This is what is meant. The SSD moisture content, or moisture content at SSD. This is what I need you to know. The 0.5 and the 0.7 for the two types, here it is. But actually, the moisture content that exists in the fine and the coarse They are in the wet. One of them is, it does have 2%. This is the coarse aggregate. And the other one, it does have 6% fine aggregate. So the aggregates are wet, and they have 2% and 6% for the coarse and the fine. This is a translation of this given information. And this is very, very important, because as I told you that you don't have in the NCAAS anything to explain this to you, and they ask you to solve this problem. And they're asking the amount of water in pound per cubic yard that would be used in the final mix is. The statement that they mentioned here, that the aggregate that they added at the SSD, I believe it should not be here. This is my, as I told you, that the translation, I gave you the translation. And when we solve the problem, probably I will solve it a couple of times. At least you can understand it, one time before lunch and one time after lunch. And we'll see what will be the effect of the lunch. Is the lunch going to increase or decrease? And I will solve it in a way, I don't know how they solve it, but I will solve it. Okay. This is how much they added coarse aggregate. As I told you, this SSD, it should not be here. It should not. And you can double check the errata. Maybe the errata, I don't know if they added to the errata or not. I will double check. They should not put the SSD here. Because if they kept this SSD condition here, the amount of the water is 305. The answer is C. If they keep this like this, my answer will be C. But the answer is not C. Because the conditions of the aggregates are different from the SSD condition. If the aggregate are the SSD condition, no adjustment for surface water. So I don't know. Why they put this here, I have no idea. I don't agree with that. And let us solve it before lunch and after that. So what I need to do, I will do it in 2 steps. I need to bring the coarse aggregate from wet to dry first. Okay? Because the wet is equal to dry times this one plus the moisture content, which is this number here, by the way, this W. Let me write it here, at least I can send it to you. This is problem number what? Number 40. And we are going to see what answer he has. 40 of the NCAAS. Because I need to take at least 5 minutes before I start the next class, because it seems to me I keep teaching all the way until the whole day without even lunch breaks. Oh my God. Everybody is not happy with me, including my wife. No problem. So he added 1674 pounds per cubic yard. This of the coarse aggregate, which is wet, according to him. And we know that the wet is equal what? Is equal dry times 1 plus moisture content. I need to get the dry weight. So the dry weight is equal wet divided by 1 plus the moisture content. So the wet weight, how much he added? He added 1674 divided by 1 plus. How much is the moisture content for the coarse aggregate? It is 2%. So this will give me a number. Let me see here. The 1.02. Okay, so 1674 divided by 1.02 equal. So this will give you 1641.18 pounds. So by doing this, I bring the coarse aggregate from the moist to the dry, but I need to bring it to the SSD. So I will say the SSD weight of the coarse aggregate. I will take the dry and multiply it by the 1 plus, so the dry, which is 1641.18 pound, times 1 plus. How much I need to reach SSD? Here it is. For the coarse aggregate is just 0.5. So times 1 plus 0.5. I do it in 2 steps. It could be done in 1 step, but I need to understand. I need you to understand. So it is 0.5. Enter. Okay. And you add 1, and you multiply this times 1641.18 equal. This will give you 1649.39 pounds. This is how much is the weight of the coarse aggregate at the SSD. What he did, what he put 1674. How much difference between this and this? This how much delta water for the coarse aggregate, which if you take this number 1674 minus 1674 equal, that means there is a 24 pounds extra water, 61 pound extra. I dump this, but it is wet. I need to keep this only, the rest will be excess water. I will do the same thing for the fine, and this will conclude the problem. So it is the dry weight for the fine. He said that he put in the fine how much? He put for the fine, he put 1100 pounds. And again, the SSD, it shouldn't be here. And after I finish, I see my solution. 1100 pounds divided by 1 plus 6%. Who said 6%? Here it is. The fine. 6% moisture. So I bring this to the dry state. So it is 1100 divided by 1.06 equal, it is 1037.74 pounds. The dry, I need to get the SSD for the fine, is equal to 1037.74. I'll multiply it by the percentage of the moisture to bring it to the SSD, which is 0.7%. So it is times 1 plus 0.7%. So this will give you times 1.007 equal. So this is 1045.00. The difference, this is what I need. The difference between this and the 1100 is the delta water. So delta water is equal what? Is equal 1100 minus 1045.00. So minus 100 equal, so this 55 pounds. This is delta water. So the aggregate, one aggregate has 24.6 and one has 455. So the total water, delta water total is equal to the 24.6 pound that coming from the course plus 55 pound coming from okay. So this will give you what? So 55 plus 24, 24.6, 24.6 plus 55 is equal 79.6 pound. This is the total water that will be extracted from the fine and from the coarse. he added, how much water did he add? He added 305. So if you take 305 pounds minus the extra water that's coming, it is 79.8 pounds, 79.6 pounds. Let us see how much difference. Minus 305 equal, oops, sorry, 305 minus 79.6 equal, I got 225.4 pounds. This is my solution. I don't know, but this is my solution based on the concept. I need you to understand the concept. Okay? And I will scan this and send it to you. Let's go and ask his solution. This is a problem. So in this case, 225 point, probably the answer B is the best. If I have a choice, I will pick the answer B. The amount of water that will be used for the final mix. Because he added 305. If he kept this SSD, the answer will be C. I don't know. And there is no need to calculate. But it seems to me that this should be out. This is what actually he dumped into the mix. This is my clarification of the problem. If you understand it as given like this with the SSD, that's fine. But for myself, or for my personal, from my point of view, since he provided the properties of the aggregates and he gave us the SSD condition, why you are giving me the SSD here? Okay, so this will be my okay clarification. But this is the right way. What I showed to you is the right and the logical way of. And I hope let me double check the answer to see what is answer number 40. So the answer is B as in boy. Okay, okay, number 40. Number 41. He ended with 221.2, probably rounding, but okay. And he said that the answer is B. He did it in one step. And I will show you the one-step operation, by the way. Okay? The one-step operation, which I solved my problems on one-step operation, but I need to break it down for you. And he is talking about this a little bit. Talk about it. Talk about, you can read this. But I don't like this approach at the beginning. I like this approach at least to show you, okay, what is meant by this. And this diagram, if you understand it, and if you understand the diagram, I will scan it also, I'll send it to you with the problem, at least translate into English. This is a translation of the problem. And if you understand this translation, I believe you are going to be in very good shape. Okay? So I hope this is the remaining topics. You can read it in your own, and I will be glad to go over anything related to asphalt or wood, okay, or soils. But this is the most difficult part, and I believe you are in very good shape right now. For example, there is one question here. Question number 38. We talked about this, by the way. Test that measure the energy required to fracture a specimen at a given temperature is number 38. Test that measure the fracture. Fracture means you break it all the way. Do you remember the Charby test? Do you remember the Charby test? You put the specimen and you hit it from the back. Charby test. Charby. You should know that. In general, a metal with high hardness test. The material that has high hardness. What does it mean? High hardness. Good formability, high impact strength, high electrical conductivity, high yield strength. Hardness. Do you remember the equation, the 500? The higher the hardness, the higher the strength. The higher the hardness, so again is D as in David or doctor. And there is a equation, we use it. So I needed to be aware of these questions. Okay. On the exam, you will not see these questions again. They are going to come up with another set of questions, and I'm sure that you will be able to answer. So I will scan these things and send it to you guys sometimes today, but let me take 5 minutes break before I start the second session, which is surveying. I'm helping the surveying group. Hopefully they will come. Okay. I'm adding all these sessions. They are not originally scheduled, but I'm adding all these sessions to help them so they can pass the exam from the first time. I hope that they will come, and you can join them if you want for free. I will talk about something related to the FE. It will help you to understand the FE section of surveying, the one I send it to you. Okay? So I will, different ID. I send you the ID, not the same ID for the FE. The ID for the other ID for the surveying, which is not for free, but I gave it to you for free. Costs a lot of money, but that's fine. Okay. Let us take 5 minutes break and come back, and I will join you also at 3 o'clock. I will start the second session for the FE7 where I cover surveying. Okay. So thank you very much for coming, and join me shortly if you are interested to join the surveying class.